So version control. Now, version control is a very crucial piece of document control, which is part of design development, configuration management, and all the pieces that go along with that. So what is version control? That is simply just managing changes to data. Now in document control, we talked about the fact that documents can change and that I want to have those revisions to them. But what we understand as we take a step back for version control is that I could change that document multiple times as I'm in the process of developing a set of changes that will then be released at once. So I have to have some way of dealing with iterations, maybe even between version releases of controlled documents. So version control captures all of those changes, not just released changes, but incremental changes as well. Anything that would manage those changes to data. When we're talking about it in digital format, you could think of it as essentially a file server that remembers changes. Okay, so if you had a file server, but you could actually go back and get a version of the file as it was in the past, and you could see how it was changed, and you could see who had changed it. That would be a version control system. There's a couple different ways that version control systems are done. One is kind of a copy, modify, write. That is where we have a central copy of the file. If you want to change it, you get the central copy, you modify it, and you put it back. And while you have it, nobody else can have it. Okay, that's kind of an older method. What would have been more done with paper, right? There was one master copy, and if it was going to be changed, someone had to go get it and change it. Another one is what's called like a branch merge, which is to say we're going to have a set of data that's centrally stored, and anybody can get a copy of it and make changes to it and then submit their changes back. If multiple changes are made to the same file, then those changes are going to be merged into a thing. And that works very well for most stuff because typically you're not going to have multiple people working in the same exact part of something, right? If you're writing a document, you don't have two people writing the same section of the document. One's writing one section, one's writing another. Those sets of changes can be easily merged together, and you don't have a thing where one person's locked out of editing because the other person is working on it. At a higher level, if you start talking about whole designs where there's multiple folders and multiple files that are all associated with that thing, if I was to go be making changes and I had to lock the whole folder tree out, nobody can make changes to anything because I'm making one little change there. It becomes very cumbersome. The version system that we use utilizes the branch merge style of changes, which is beneficial. So the tool that we're using is called Subversion, abbreviated SVN. It is a piece of software that is a version control system. That's what it is. It helps with software configuration management. Again, those control of releases of software or other digital data in general. It's really the underpinning of our document control system and our configuration management. So the SVN, the subversion system, is pretty important to understand and be able to use. To get some of the concepts into place, why do we use subversion or version control system in general? The configuration management, right? We talked about that idea of how do we know when things have changed? How do we know when software has changed? How do we know when parts have changed? We need to have some way of identifying those particular both releases and things that are not released but that are used internally. How many times have you done a project and you're like, okay, I know I tried that before and it worked, but now it's not, something's not working. I want to go back to the version that did work. This lets you be able to do that. To allow for the team to collaborate. Without a version control system, I have a set of files, you have a set of files, we have to have some way of getting our stuff back in sync. And how do we do that? Version control system lets us access new information that the other team members have done, very quickly and make sure that we're getting changes that people have done propagated across the team with very little effort, so that you don't have two people trying to do the same thing. If you didn't know that someone already put together the parts list and you're going ahead and trying to build a parts list so that you can do some other set of work, you're duplicating effort that's already been done. If it's in the version control system, then you can quickly see that someone's already done the parts list and move on with whatever else needs to be done. There's also Defense Department requirements for auditability of changes throughout the design process. Version control system gives that to us automatically. Big aspect, data backups. Right, if you have a set of files on your computer and you have a set of files on your computer and have 25 people with a set of files on their computer, they all could be a little bit different. Then I have to have a mechanism of backing up everybody's computer, which is cumbersome, and I have a lot of redundant data in my backups because 90% of what everybody's computers has is the same sets of data, or has a lot of overlap. But if everybody's computer is just referencing the central storage, the central version control system, then I just need to back up the version control system, and I have backups of all the data that's stored in the version control system. And that prevents data loss from local machines and also just inadvertent changes. If something happens and was done because of the fact that I have change history, I can always undo those things. If somebody deletes a file, a whole folder, no big deal. I can go and undelete it because I have all the history still stored. So those are some very big benefits to Subversion or a version control system. So how does it work? What does Subversion look like? So we're specifically talking right now about the Subversion version control system. Some terms: repository. Subversion repository is the central store of the version data. You could think of it as the server that the clients pull the data from. You can get to it via the repository browser, and you get it onto your machine via a process that we call a checkout. There's also a web view of our version control system that you can look at. We'll look at that at the end, and you can see. Now, you can have multiple projects in a single repository, or you can have multiple repositories for various projects. We have both at Duotech. We have one major repository that's used for a lot of small projects and some bigger ones that tracks a lot of the document number systems. But some of our very large projects that encompass a lot of scope have their own repositories as well. So the source link on the document control system will help you find which repository you need to go to get the design files for a specific thing that's being worked on. So the repository stores the central storage of all the data, and you get that onto your machine by checking it out. Now, the repository tracks changes through what's called a revision. A revision in Subversion is global. So that means that anytime any file in the repository is changed, the revision of the entire repository advances. You don't have version 1 of one file and version 15 of another file. The whole repository is at version 15. Now that does mean that a particular file will skip revisions, in the sense of this file might have only been changed in revision 5 and revision 20. Now, I could still look at that file as it existed in revision 12, but it's going to be the same as it was in revision 11, 10, 9, 8, 7, 6, and 5, right? It's going to be the same thing. But that revision, so that revision number being global is also, you could think of it as a snapshot of the whole repository at a given instance, a given revision of the entire repository, a given point in time. So after every change that any user makes, the whole revision advances every time. Checkout. This is the way that the users get a copy of the central data onto their machine. The thing that's on your local machine is called a working copy, often called a sandbox. Those are two terms that you'll see or hear being used. Generally, you will never check out an entire repository. Generally, you will do what's known as a sparse checkout, and you will get only the pieces of that thing that you need. A couple reasons for that. One, a lot of times a repository will have what are known as branches tags that are copies of the data that have been pulled out at particular points in time for particular purposes. There could be branches being worked on by other people, and you don't need everyone else's branches, right? So you're going to just be getting a checkout of the appropriate pieces that you need to be worked on. Just for data management purposes, that's helpful not to have, you're just cluttered. Another thing is that when you do a checkout, just to be aware of, that you check out 2 copies of everything that you check out. You have the working copy, and then there is a hidden copy that is the copy of the file as it was when you checked it out. And that's what your local machine uses for comparing to know what has actually changed on your local machine. So every file you check out from the repository takes up double the disk space on your machine. So just to be aware, if you check out 200 megs of CAD files, you just took up 400 megs of disk space. So you're just going to want to get the thing. Also, when you do a checkout, not only can it point to just parts of the repository tree that you want to see, it can also be at any point in time. I can check out a version of a file or of a section of the repository from last week, from last month, from last year, at a specific date, at a specific revision. I can get just that thing. So that is a very useful tool when you want to go back and look at something. An update is the process of getting the changes from the server onto your machine. So even if you don't do anything, you're just referencing the repository, you want to do updates periodically to make sure that the changes that are on the server get brought down onto your machine. You want to update pretty often. You don't want to be out of date as you're going through the thing. You also are required to update before you do a commit. A commit is how you send your local changes up to the server. If it goes well, you'll create a new revision. If it doesn't work, then the whole commit is aborted. So when you do a commit, it's what is known as an atomic commit. It happens either all or nothing. So that's a very useful thing. If you were doing software change, for example, and you changed multiple files and they all need to be changed because they reference each other, you don't want one file to successfully change and one file not to change on the server. So if for some reason there's a conflict or something doesn't happen, the commit doesn't work, the Subversion server will make sure that the whole thing is rolled back so you can fix the issue and make a successful commit. Once the commit happens, the version does roll. You want to make sure that you commit fairly often. You want your changes to be going to the server, to let people be having access to them, to make sure that they're going to be backed up, to make sure that you're not working too long without other people knowing it, which increases your chances of having conflicting data sets. But at the same time, you don't want to just be committing every 5 minutes or committing stuff that isn't even workable, right? There's no need to be doing that. You want to commit somewhat logical changes. If you're in the process of designing something and you're making a series of changes that are all related. I've got 2 different parts. One of them has to have some additional holes added, and then the other one's going to have additional screws added, right? Commit both changes at once. That's one logical change. Don't commit just the part with the holes and come back later and commit the part with the screws, because they go together. Tie those things together into a single commit. You can commit multiple files at once. And leave descriptive logs when you commit. We'll talk about that a little bit more. But when you commit, there's a log file attached so that everybody can see who made this change and what did they say about the change. The system will already tell you what the date was, what the version is, what files were changed, whether they were added, deleted, modified, whatever. So the logs that you're going to be leaving are what did I do and why. I added these holes because the mounting bracket was oriented differently than I thought it was, right? I added this I added new parts to the parts list because they were, missing in the previous version. Whatever. It doesn't have to be long. Just give something so that someone's back looking at the history, they can know why that thing was done. There's another thing called branching and merging. I'm not going to jump into this a whole lot. It is a little bit more of an advanced part of Subversion, but basically you can create copies within the version control system for free, because the version control system recognizes changes and recognizes history. If I say I want to create a copy of this file right in a different place, all it does is it creates a little metadata thing that says there's a file now by this name in this place that's an exact copy of this revision of this file in this place. And that's all it is. It doesn't actually on the server create another file. It just makes a little tag that says this file, or even this whole folder structure, has been copied over here. That's a branch. You can do that for a number of reasons. You can do that to say, this was the one that worked when I ran the test the other day. Here's the copy of the whole thing that I liked. I'm not going to check that out normally, but if I needed to, I could go on that branch and do it. Another reason for doing a branch is to say, I need to make a series of changes, but other people need to be referencing this data while I'm doing it. I want to be able to have my changes tracked, but it's going to take me a week to do it. So I'm going to create a branch over here, and then I'm going to work in the branch so that I can keep committing my changes, but it's not going to keep changing the stuff that people are referencing with stuff that I'm in the midst of working on until I get it done. And then I can merge that branch back in one big jump. And then everyone else will see their main line just go from version this to version this with all of my changes that were incorporated through that. If you get to those points where you need to do that, get with myself or your supervisor to work through some of those processes. You can also end up with a merge if two people do happen to work in the same file, which can sometimes happen. So two different versions of the same item can need to be merged together. The system will always try to work that out as best as it can, although, to be fair, with the SolidWorks and SolidCAM binary files, it doesn't do as great of a job. On Windows, we use a program called Tortoise SVN. It's a plugin that allows you to both access the repository, but also all the process of updating, committing, checking out, branching, merging, and doing other operations within your local sandbox and on the server. The root directory for our Subversion is listed there, svn.services.dsi. You currently have the link on your paper, but I will be getting with each individually to actually create your password for accessing the Subversion system. Stay current. You need to make sure that you update regularly, especially before you start editing something. You don't gain anything if you're not working with the most recent version. You could very well be doing work that's already been done or undoing changes that have already been made. So you want to make sure that you stay current, because the longer you wait, the more likely you're going to have problems down the road. You also want to commit pretty regularly. Don't be making a lot of changes without letting other people know. It doesn't matter how often other people are updating. If you're never committing anything, they can't know about it. Don't add temporary files to the version control system. If you have dot files, temporary files, log files, build files, a lot of software will create these little things within a project directory. You don't need to add those to the repo. Chances are the other person's computer's already created a bunch of them anyway, and they just don't need to be stored on the server. There is a method of using the SVN, what's called SVN ignore, which will basically prevent the system from continuing to prompt you to add those files. Again, that's more details, but don't be adding those. Don't add the output files. The version control system is for tracking the source files, not the output files. There are a few exceptions to that, particularly for the mechanical. The CAM files we do commit. The CAM G codes are output files, but those are ones that we do actually commit, because tracking the changes to them is is useful. But if you have a Word document and you generate a PDF, don't commit the PDF, just keep the Word document around. If you have a circuit board file and you create the Gerbers, you don't commit the Gerber files because we already have the circuit board. The Gerber files might be released, but they're not going to be committed in the version system. If you write some software, don't commit the binary. Anybody can take the source code and compile it themselves. So, output files don't get put on there. Don't copy files, right? It's a habit that is very common when you're working without a version control system. What do? You copy the directory out. This is where it was yesterday. This is where it was last week, right? You make those copies. You've probably done that so that I can go back to it. What you're doing is you're doing version control and you're doing it badly, right? The version control system already handles that for you. If I need to go back, the version control system can let me go back. Don't copy the files around just for the purposes of archiving them. One of the main things that would cause you to do that, though, is if you put the revision level in a source file. You never version the source. The version control system already associates the metadata with that file of what revision it is. So if you have a SolidWorks model, for example, that is always, the file name is always 357-5126. Even as that file goes through revision A, revision B, revision C, the actual file doesn't get named that. The source file does not have dates, does not have revision levels in it. The system already tracks that within metadata. Use Subversion for making file system changes. If you're going to rename a folder, if you're going to rename a file, don't just click on the file and rename it. What'll happen is that you'll end up with a new file that's created that the system doesn't know was associated with the old file. So it breaks the history that's associated with it. But if you use the Subversion rename, then you can rename that thing and it remembers, oh, this new name was this file back here at this revision, and you get all the same log history and everything that goes along with it. So always use the SVN move, SVN copy, SVN rename if you're going to make changes to the files. Try to use ASCII formats if whenever possible over binary blobs. You're pretty much going to be dictated by the software that you use, but the version control system can do a lot better with files that are text than files that are opaque binaries. Don't let your sandbox get out of date. That's another way of saying stay current. Update, commit often. Descriptive log messages, we talked about that. Don't leave a blank message. Don't write a vague message. A message that says fixed stuff does me no good. Does you no good next week when you're like, what did I fix? Try to write a little bit about what you did. There's no point in telling me that you added a new file. I know you added a new file. The version control system tells me you added a file. So I don't need to tell me what that already says. Don't say, I updated the parts list. I know it says parts list was modified, right? Don't say the thing I already know. Tell me why it happened. Tell me what about the parts list changed. There's a command for exporting. If you're gonna, for any reason, create an archive copy, a CD of a release of something, there's a method for export, and what that does is it takes away all that temporary files that Subversion uses for the metadata information. It just creates a plain file system export. Not often that you'll use that, but if you do need to make an export, make sure to go ahead and do that.